A 31 billion parameter model now ranks number 3 among all OpenAI models in the world, and it fits on a single GPU. Google just released Gemma 4, and if you build anything with AI, this changes the math on what you can run yourself versus what you pay someone else to host. Here is what happened. On April 2nd, Google DeepMind launched Gemma 4, a family of 4 open-weight models built on the same research foundation as their flagship Gemini 3. The lineup spans 4 sizes: a tiny effective 2B and effective 4B designed to run on phones and Raspberry Pis, a 26 billion parameter mixture of experts model optimized for speed, and a 31 billion parameter dense model optimized for raw quality. All 4 ship under the Apache 2.0 license. That last detail matters more than the benchmarks. Previous Gemma releases used a custom license that created legal gray areas for commercial use. Apache 2.0 removes that entirely. You can modify it, redistribute it, sell products built on it, and Google cannot change the terms on you later. Hugging Face co-founder Clement DeLange called it a defining moment, saying local AI is having its moment. Google DeepMind CEO Demis Hassabis went further, calling these the best open models in the world for their respective sizes. Think of it like this: until recently, running a genuinely capable AI model meant either paying per token to a cloud provider or buying enterprise-grade hardware. Gemma 4 moves the threshold. The 31B dense model, which outperforms open models with 70 billion or more parameters, runs on a single 80GB Nvidia H100 GPU at full precision. Quantized versions run on consumer hardware. The small models run entirely offline on an Android phone with near-zero latency. That is a fundamental shift in who gets access to frontier-level capability. Now let me tell you what actually changes if you are a developer, a product lead, or running a business that depends on AI. First scenario, you are building customer-facing AI agents. Gemma 4 has native support for function calling, structured JSON output, and system-level instructions baked in. That means your agent can reliably call APIs, interact with external tools, and follow multi-step workflows without the brittle prompt engineering hacks that plagued earlier open models. You can deploy this on your own infrastructure with 0 per token costs after the initial hardware investment. Second scenario, you run a development team and you are paying for cloud-hosted coding assistance. Gemma 4 supports high-quality, offline code generation. You can set up a fully local AI code assistant on a workstation, keep proprietary code off third-party servers, and eliminate the recurring API bill. Third scenario, you are building products for global markets. All 4 models process images and video natively. The smaller models also handle audio input for speech recognition. Context windows go up to 256,000 tokens on the larger models, and the entire family is trained on over 140 languages. If you need multilingual document processing or visual understanding at the edge, this covers a lot of ground without stitching together 5 different services. But let us be honest about the limits. Proprietary systems from OpenAI, Anthropic, and Google's own Gemini still lead on the hardest benchmarks. If your use case demands absolute peak performance on the most complex reasoning tasks, closed models remain ahead for now. Second, running the 31B model at full precision requires serious hardware. A single H100 GPU is not cheap. Quantized versions trade some accuracy for accessibility, and you need to test whether that trade-off is acceptable for your specific workload. Third, the real proof comes from production, not leaderboard scores. Early adopters will need to stress test function calling accuracy, multi-turn planning reliability, and tool use consistency in their actual environments. Benchmark rankings do not always translate to real-world robustness. And finally, open weight does not mean open data. You still do not know exactly what the model was trained on, which matters for compliance in regulated industries. Here is what I would do in the next 30 days if this is relevant to your work. 1. Download the 31B or 26B model from Hugging Face, Kaggle, or Alima, and run it against your existing evaluation suite. Compare it directly to whatever model you are currently paying for. Focus on your actual tasks, not generic benchmarks. 2. If you are building agents, test the native function calling and structured output capabilities against your real API endpoints. Measure reliability over hundreds of calls, not a handful of demos. 3. Try the E4B model on an Android device or edge hardware. If you have any use case involving on-device inference, image understanding, or speech recognition, this is the fastest way to see if on-device AI is finally practical for your product. 4. Review your current AI spending. Calculate what percentage of your inference costs could shift to self-hosted Gemma 4 models. Even a partial migration can meaningfully reduce your monthly bill while giving you more control over data residency. 5. Talk to your legal team about the Apache 2.0 license implications. If your previous hesitation about open models was licensing risk, that objection is now gone. Make sure your team knows it. The bottom line is this: Google just made frontier-class AI capability something you can own, run locally, and build on without legal friction, and that reshapes the economics of AI deployment for every company paying per token today. If you want to stay ahead of these shifts, subscribe to AI Blueprint. We break down the AI news that actually matters for your business every week.